All right, my name is Steve Wilson. I'm with ColdJet. We make cleaning cool. We take solid CO2. We call it dry ice. That becomes our cleaning media. It's for those who want to clean dry, you want to be non-abrasive, and you want no secondary waste. The magic actually begins with the actual dry ice itself. This is CO2 in its solid phase. It wants to go back and be a gas. You can see the dry ice is sublimating and wants to be a gas. On impact, it will sublimate immediately and go to gas. This dry ice is put into a machine like this particular press, or at this point I got this one hooked up. We take the liquid, we take the actual dry ice solid particles, put it into the machine. Then you choose the size particle you want to blast with. This machine allows you to blast with 3 millimeter if you want. You can stay at the full 3 millimeter pellet, or you can cut it all the way down to a sugar size particle of 0.3. We set the pressure and we set the feed rate. You're going to see three things happen when I clean this tool. There's going to be some kinetic energy. The dry ice is a very soft media. No Rockwell number because it's frangible, but there is a Mohs scale of hardness. It's about a 1.5 on a 1 to 10. 1 being a talc, a diamond being a 10. Your fingernail is about a 2.5. So it's a very soft media, so I got accelerated about 1,200 feet a second. You're going to see some kinetic energy micro crack that contaminant. It's minus 109 degrees. It's very cold. That cold will embrittle the contaminant. It'll cause the contaminant to shrink. It'll lose its bond strength because I froze it. It's coefficient thermal expansion contraction of dissimilar materials. The contaminant's not the same as the P20 or your H13 or your aluminum mold. The last thing you're going to see is the fact that the dry ice sublimates. It's going to phase from a solid, go back to a gas, and in so doing will volumetrically grow about 800 times in size. So I'm going to micro crack it, shrink it, and blow up the contaminant. I'll start with just blowing air. If we blow air only onto this tool, it won't clean it. Air alone will not bring us cleaning solution to this. We bring in dry ice into this solution. I will clean in these very complicated places to clean, places you need a Q-tip or a pipe cleaner to get down into these joints. So now we're going to get some dry ice into the game. Now you're very quickly and effectively cleaning each cavity out on the processing line while the mold is still in the press. You're cleaning at operating temperature. You're cleaning each cavity one by one, removing what would be off gases from the different resins. It may be a sacrificial mold release agent. It could be buildup actually excess polymers on the mold. But little by little, you're cleaning each cavity, and what would have taken hours, you're now cleaning in minutes. Normally this mold, which is a rubber tool, would have to be cooled, cleaned, and then reheated. And we just clean it in a matter of seconds. That's dry ice cleaning. It allows you to clean online at operating temperatures to clean tooling, whether it's on the process line or back on the tool bench.